When we consider differentiated instruction, we're talking about meeting the needs of all students. And when we refer to all students, some people think all students within general education, but that includes students with special needs as well as gifted students. So we're looking at all students, really meaning all students. And in order to differentiate and meet the needs of different learners, we need to use different strategies to do that. So when we're looking at math, that's usually a challenge because there's so many different levels of math within one math class. And the CRA method with the concrete, representational, and abstract is one of those tools to be able to meet the needs of multiple students. So in the areas of math, there's 3 general knowledge areas in order to be competent in math. One is computation of the skills and facts. The other one is conceptual understanding. And the third is problem solving. And those 3 together are interdependent, but yet each of them need to be considered separate when we're doing our instruction in order to meet the needs of students. When we handle them differently, the goal of a skill or a fact is fluency and automaticity. So we want students to be able to do computations quickly without a whole lot of working memory involved so that they can produce facts very quickly. So we have students doing a lot of practice on addition and subtraction, multiplication facts. So the goal there is very different than with a conceptual understanding, because the goal of a conceptual understanding is concept attainment, which means they're able to transfer that information as well as use it to analyze or apply that information to other things. So those 2 are very different, and because of that, they have to be handled very differently in instruction. And using our CRA model, when we look at the concrete level, using manipulatives to teach, that's where you'll see some major differences. For instance, if we have a struggling learner who is unsure of the multiplication fact of 3 times 4, we might teach that student using concrete objects or manipulatives and say, here's a group of 3, here's a group of 3, a group of 3, and a 4th group of 3. And the student can then count them up to come up with 12 in order to calculate it. So we use those manipulatives in order to support that learner. It's an aid to help them because it holds the place value of numbers and things like that. So at the concrete level, when we're talking about skills, that's used as an accommodation. With a conceptual understanding, we have to handle that differently because a conceptual understanding, for example, might be the properties of multiplication. That would be, so when we look at the commutative property of multiplication, 3 times 4 equals 4 times 3. A student can easily memorize that, which would be at the abstract level, but the challenge then comes in giving them those same manipulatives and saying, show me why that works. So we're adding an element of challenge by providing those manipulatives, because then the student has to recreate their own understanding using objects. And by doing that, the concrete objects become an additional challenge as opposed to a support. One of the things that we can do for conceptual understandings is starting by providing the abstract, giving them the answer. For in that example, 4 times 3 equals 3 times 4. We're not asking the student to do the computation, we're asking the student to show their understanding. We've always thought of math as a very linear process, very fact-based, with right and wrong answers. And current trends in math are really changing that to get students to think more. And when we talk about that conceptual understanding, we look at being able to ask open-ended questions and questions that have multiple solutions to it. So for example, using that same analogy of the conceptual understandings, I might provide the abstract and then ask them, show me how this could be done. They could come up with multiple ways to show me how a particular problem is done, creating their own system or going with a system that they've learned through computation. But by using open-ended questions or providing those answers up front and having students work backwards from there, we're able to differentiate and support at the different levels.